Today, with this video, we will be learning about how much borrow area soil will be required to construct a certain quantity of embankment once the densities are known and water content are known. The question is: a soil has density of 1.75 gram per cc, water content of 12%, the specific gravity of soil is 2.7, the soil is compacted to water content of 18% and dry density 1.6 gram per cc. For 1000 cubic meter soil in fill, estimate the quantity of soil to be excavated by the borrow pit in cubic meter, the amount of water to be added. The deliverable is how much soil to be excavated from the borrow area and the amount of water to be added. Strategy to solve this kind of question, we must find out what is the dry density of borrow area soil, and if it is not given in embankment, we should find out dry density of the embankment soil. Since if dry density we know, we can know the mass of soil solid. The related mass of soil solid upon volume is the dry density. Since mass of solid will remain constant for the borrow area soil as well as the soil brought into the embankment. Only variable is the voids where water or air is available. So we must find out the dry density whatever parameter is given. So let us find out the dry density of the embankment soil. The dry density of embankment soil is already given in the question. The dry density rho d is given 1.65 gram per cc, which is nothing but 1.65 ton per meter cube. Volume of soil, volume of soil, soil is given 1000 cubic meter and water content W is given 0.18 in the question. Now we know the relationship. Dry density rho d is mass of dry soil upon volume. Rho d is given 1.65. Mass of dry soil we need to determine and volume is 1000. So mass of dry soil will be equal to 1.65 into 1000. So it will be equal to 1650 tons. Mass of dry soil will be now borrow area. Bulk density of borrow area soil rho suffix t is 1.75 gram per cc, which can be written as after conversion 1.75 ton per meter cube. We know the relationship between the bulk density and the dry density. Bulk density rho suffix t is nothing but rho suffix d 1 plus water content W. Let us input the values. Rho t is given 1.75. Dry density we need to determine 1 plus water content of the borrow area soil is 0.12 given in the question. Water content is 0.12 given in the question itself. So dry density of borrow area soil. Rho D is equal to 1.75 upon 1.12, which is equal to 1.75 divided by 1.12 equal to 1.5625. So 1.5625 is the density of borrow soil, which is ton per meter cube. Once we know the dry density of borrow soil, rho D is 1.5625 ton per meter cube, which can be rewritten as 1.5625 mass of dry soil borrow area of mass of dry soil to be brought from the borrow area is mass of dry soil to be brought from the borrow area is equal to the mass of dry soil required in the embankment, which we had already determined in previous slide, which had come to be 1650. So that value we will do input here. So to find out the volume of soil required from the borrow area, whose dry density is 1.5625. So let us input 1650 mass of dry soil required to construct the embankment upon the volume to be brought from the borrow area. So volume borrow area soil will be 1650 divided by 1.5625 equal to 1650 divided by 1.5625 is equal to 1.5625 is equal to 1056 cubic meter. Volume to be brought from the borrow area is 1056 cubic meter, whose bulk density was 1.75 to make dry density of 1.65 to construct 1000 cubic meter of borrow area. So the borrow area soil is more than the soil required in the compacted soil in the earth, in the field. So sometimes this dispute arises. You brought only this much soil and in the measurements are only 1000 cubic meter. So resolve this kind of dispute. This kind of question and solutions are very important. Now, how much water required required to be added in borrow area to achieve the required water content required for the construction for the final construction of embankment. We know that final compaction is achieved at optimum moisture content. Borrow area will have certain quantity of water inherent with it. So we must first determine how much water is available in the borrow area soil and how much water we should add to achieve the optimum moisture content to get the maximum dry density of the constructed embankment. So we know that water content is nothing but mass of water to the mass of soil. Now mass of water we need to determine a borrow area whose water content is 0.12 and soil solid is 1650. So mass of water available in borrow area will be 0.12 into 1650 equal to 198 tons. 198 tons. We also know that density of water is mass of water to the volume of water. So volume of water will be mass of water which is 198 tons and density of water is 1 ton per meter cube. So mass volume of water will be 198 cubic meter. The volume of water available in the borrow area soil is 198 cubic meter. Now we should determine how much water will be required to get OMC of 0.18. So water content of embankment is 0.18 and mass of solid is 1650 tons. So mass of water will be equal to 0.18 into 1650 equal to 0.18 into 1650 equal to 297 tons. Again mass of water upon volume of water is density of water. Now we need to know volume of water. So this will be equal to mass of water upon density of water, which is nothing but 1 ton per meter cube, and mass of water is 297 divided by 1. So equal to 297 cubic meter. The amount of water to be added will be A, amount of water available in the borrow area soil, and B, amount of water required to achieve 0.18. So the amount of water to be added additionally will be equal to 297 minus 198 equal to 297 minus 2 this will be equal to 0.18 into 1650 is equal to 297. So 2